Evelina and Dimitri invited artists from different disciplines, so you get each with their own project coming to the table. So the setup is quite elaborate, so you need each other to make a final photogram.
It is very interesting to notice how molecules interact with light, and these molecules can be part of living systems, making use of the energy of the light for to sustain its own life, while other molecules are not embedded within a living system, but still show this transformation. It makes you wonder where is the border between life and non-living systems. So in photosynthesis, light is being utilized by specialized protein complexes. They function like solar cells. Light is absorbed and the energy is transformed into an electron flow and a proton flow, and that is used to create fuels. Fuels that are stored and can be assessed whenever an organism needs that energy from that fuel. Sunlight is white light. It consists of many different colors of light, and nature adapts to those different colors. So if you have an organism that lives deep in the ocean, it will try to harvest different colors of the sun than if you are living on the land. And that is because the water absorbs a lot of the wavelengths that are actually reaching the earth, but not penetrate the ocean too deeply. And what you can see is that these light-activated molecules slightly change properties to accommodate for this. So if you are 100 meters deep in the ocean, there's not so much light, but still the few photons that are being reached there per second can be utilized to sustain life. And life is all about transformation, and what we have seen, what you see when you take a picture, a photograph, is the transformation of the materials of the photographic paper, depending also on the color of light, if it is prepared in such a way. There is a lot of randomness in that, and a lot of trial and variations that we also see in the radiograms here today. That is definitely has an analogy, I would say, in evolution, because that is how different organisms came about. Randomly they changed these molecules, these exact photo-absorbing pigments, and see if that would work better or worse than before. In photosynthesis, symmetry plays a very big role, because in photosynthesis there are different processes of light absorbance, light energy transmittance, and light energy transformation. Those are three different processes, but they're all carried out by the same pigments. And the symmetry and or the absence of symmetry actually determines the specific process that occurs. So nature also shows that you can play around not only by changing pigments to accommodate for different colors of light, but also by changing the geometry, how pigments are arranged relative to one another. Very symmetric, then it mainly geared towards absorbance and energy transfer, or very asymmetric, in such case, for instance, electron transfers occur.
For me, as a photographer, I'm very interested in this kind of analog processes where you experiment with paper and direct exposures.